Hello, I'm back. All right, where were we? I believe we are about to move into the hypothalamus. We get this booted up for you. The hypothalamus below the thalamus. There, now the video should show up for everybody. So I was mentioning that my dogs look at me like I'm crazy. There's one of them looking at me. That dog's name is Barky, and he is 6 years old. My wife named him after Marky Mark because she loves Mark Wahlberg. So that's how we got Barky Mark. Anyway, he's looking at me like, Dad, who are you talking to? Shouldn't you be scratching my head or feeding me or something? And you see he's hiding behind the doggy exclusion device. He hasn't figured out that he can jump right over it yet. Anyway, back to the hypothalamus. The hypothalamus is connected to the pituitary gland, and there's that word. I mentioned it the other day, hypophysis, another name for the pituitary gland. So hypophysis equals pituitary gland. By means of a stalk, it used to be called the connecting stalk, but now we must call it the infundibulum. So it's a little connection between the hypothalamus and the pituitary by which the hypothalamus can more or less pull the strings and control the pituitary gland. The pituitary gland secretes at least 8 major hormones. Now, as I like to say, words have meanings. So, I must ask you this. Not in yellow, I don't like that color. This color. Why is that word there? Well, at least means 8, but maybe more, doesn't it? If you ask me for some money, I won't give you any. But I might say, I can give you at least $8. Well, then you might get 9, you might get 10, but you're at least going to get 8. So this sentence here says pituitary secretes at least 8 major hormones. That means, well, there's room for discovering some more. The pituitary is 2 discretely different type of organs. The posterior is made up mainly of neural tissue that secretes neurohormones, and it stains. I know Dr. Wynn is going to show you a microscope picture of the pituitary, and you're going to have to decide whether you're looking at the anterior or posterior pituitary. The posterior pituitary, being mostly neurotissue, is going to be a lot lighter stain. The anterior pituitary is made up of glandular tissue, which falls under the epithelial category of tissues, and it will stain much darker. So the posterior will stain lighter, the anterior pituitary will stain a lot lighter. So the posterior pituitary along with the infundibulum make up the neurohypophysis. So this is the nervous tissue type part of the pituitary gland. So now up here, let's start at the bottom of this slide. Just to be clear, so we're all on the same page here. The nervous system is broken down into, we break it down into 2 categories, the central nervous system, CNS, and the peripheral nervous system, the PNS. And a bundle of cell bodies, the cell bodies of the neurons, all bunched together. In the central nervous system, it's called the nucleus. And the plural of that word is nuclei. In the peripheral nervous system, a bundle of cell bodies is called a ganglion. And the plural of that word is ganglia. A bundle of axons in the central nervous system is a tract. And in the peripheral nervous system, that would be called a nerve. So the posterior, go back up to the top of this slide. The posterior lobe of the pituitary gland is neural tissue and is derived from a downgrowth of the brain. Literally, during development, I think we have a picture of this later, a little piece of brain buds off and travels and becomes the posterior pituitary. it is connected to the hypothalamus by way of, let's take a look at this word here, this phrase here, hypothalamic hypophyseal tract. Hypothalamic hypophyseal tract. So now we know that a tract, we go down here, a tract is a bundle of axons. So these are going to be the axons that have their nuclei, their cell bodies, up in the hypothalamus. The tract is going to be the axons that run through the infundibulum and synapse with cells, synapse down in the pituitary, the hypophysis. So hypothalamic hypophyseal tract. So a lot of words there. I know, I get that. Is just the neural connection between the hypothalamus and the posterior pituitary. The posterior pituitary secretes two hormones, oxytocin and antidiuretic hormone, conveniently abbreviated ADH, antidiuretic. So now let's stop for a second and think about what antidiuretic means. What is that going to do? Why would somebody, or what would happen if somebody took a diuretic? A diuretic. That would cause them to release water, right? Well, an antidiuretic hormone then would cause somebody to retain water. Retain water. So what happens here with this next sentence here says hormones are stored in axon terminals in the posterior pituitary and are released into the blood when neurons fire. Let's take a half a step back here. What happens in the nuclei up in the hypothalamus, that is where the hormones are going to be synthesized. They're going to be made up in the nuclei in the hypothalamus. They're going to be transported down the axons that run through the infundibulum and stored in synaptic vesicles down at the posterior pituitary. When it comes time to release some of those hormones, then the action potential will fire, and when it arrives at the synaptic terminal, that will cause the release of these hormones by exocytosis, just the same way that acetylcholine was released at the neuromuscular junction. So here's our diagram. So what we have up here, hypothalamus. Here we have the different nuclei where the cell bodies are. Those cell bodies are connected by axons that run down the infundibulum to the posterior pituitary. In comes an artery. When the time comes, it will pick up those hormones and carry them off. So this is the hypothalamic hypophyseal tract, the neural connection between the hypothalamus and the posterior pituitary. We're going to have something different over here in the anterior pituitary, so hang on. And this diagram is in your book, and it's a good diagram, and very good, and it'll describe, it'll say pretty much in different words the same thing. Same thing I was just mentioning. The anterior lobe is derived from an outpocketing of the oral mucosa. So that's the roof of the mouth. And during fetal development, at the same time as there's an outpocketing of the brain to form the posterior pituitary, there's an outpocketing of the oral mucosa, a little bit bubbles up and sort of merges with the posterior pituitary. Now it's connected vascularly. That is, blood vessels connect the hypothalamus to the anterior pituitary by way of the hypophyseal portal system. And it consists of the primary plexus, the portal vein, the secondary plexus. I'll talk about this from the picture on the next page. The hypothalamus secretes releasing and inhibiting hormones that control the anterior pituitary. As a matter, once again, it's very vague which direction it goes. There's lots of different possibilities. That's true. I'm going to focus on the releasing hormones for this chapter. So here is the hypothalamus. We have the artery, hypophyseal artery comes in, picks up hormones that are released by the hypothalamus in the primary plexus. There's a capillary bed. I know we haven't talked about what that means yet. Small blood vessels. Capillary bed picks up the hormones from the hypothalamus, carries them a little ways through the hypothalamo-hypophyseal portal system, where then the secondary plexus, the second capillary bed, is in the anterior pituitary. So that's unique. A portal system is where you have one capillary bed that coalesces into a vein and then a second capillary bed. The only other place in the body that I know of where this occurs is between the digestive system and the liver, the hepatic portal system. The reason for this is, we'll talk about this in the blood vessel chapter eventually, is that there's a lot of friction in these little blood vessels. So you lose a lot of blood pressure, and it just really doesn't want to flow that well through the second capillary bed or plexus. And so this is very rare in the animal world. But there's one place where it happens. So, where is that? Page down. So the posterior pituitary, you know what, let's just cut this one off for now, where I'm coming up against my time limit. Maybe one day this will work a little better for us, but right now we just got to keep them short and sweet, and I'll be back in a minute.